Mr. B, this is just a quick little tutorial on setting up the digital dice for PLD mode. Um, so just as a reminder, so you probably haven't done this in a while, you're going to need to go to New, PLD Design, and give it a name. Obviously do something like, I don't know, Dig Dice, something like that, whatever you want to do. I'm trying to type with one finger here. So not working out so well. You hit Next. You have to uncheck all. And what I want you to do is, you'll see here, GPIO 0, 10, 12, 14, 16. That's what I need you to get. So you just check those guys, 10, 12, 14, 16. I think that was it, right? Oh, I forgot 10. I knew I was missing something. All right. And so you'd hit that, and you'd start out with that stuff. Um, the first thing that I want to point out is that these guys, when you pull them in, double click on it, by default it has it as an input. If you click on this, you can see you can make it an output or bidirectional. We won't have any instances where we have it bidirectional. In my career, I can think of very few times where I actually had that happen as well. Most of the time it's either an input or an output. Okay, let's look back at the other circuit that I've already made. And you're going to set up your flip-flops. Where you get these, by the way, is right here where it says place flip-flop. The one over is a latch. We don't want that. And just for consistency amongst the group here, let's just pick the JK negative edge triggered flip-flop. Okay, there is a positive edge trigger. There's some other ones. There's D flip-flops. Let's just go with the JK negative edge triggered. Okay, so that's what you'll have. And when you put it in, it's going to have some extra text on there. What I did is I double clicked on it, and you can see the stuff that I shut off because that really doesn't have any value. I copied and pasted it 3 times, and I hooked up on-page connectors in case you forgot where to get those. Place connectors, on-page connectors, and then you give it a name. Now you notice that I named this A, that B, and that C. And that I labeled this so I remember to tell you guys this. Remember, this is my most significant bit when it does the counting. I'm not showing you how to hook the whole thing up. You guys can do that. This is my most significant bit when I'm doing the counting. Now think about the truth table that you did for the digital dice. You've got something like this, only it's filled in with, with numbers. What is A? Is A the most significant bit or the least significant bit? And of course, most of the time, when we're not designing counters, we're just looking at a binary number, most significant bits all the way to the left. And so that's the first little error that's common, is to mix A and C up. Now you want that to be A. And what you'd be doing that information, the count, you're basically making a counter to cycle through the truth table automatically. That's it. And then what I'm showing here in this black box, which is nothing there, just in case you're wondering, what that would be your logic that you derived from your truth table. So doing the same skills that you did way back when you did the birthday circuit, same idea here. You're going to have logic gates under here, whether it's AOI, NAND, or NOR, whichever one you think is the best. And then those outputs will drive GPIO 10. And GPIO 10 is going to be the blue wire on the circuit that I've made for you. You got GPIO 12, 14, and 16. And did I do this right? Yeah, I got L3 and 7. What I did here is I put on on-page connectors there as well. So what I want to do now is talk about inputs versus outputs. Okay, this is going to be my least significant bit on the counter part of this circuit, this sequential logic. And of course, we always have a clock, and that drives the first flip-flop. First thing is, well, where the heck did I get that clock? I got it right here. Place digital source, and you put a clock on. Now you notice by default, just like in the regular multisim stuff that we've done, 1 kilohertz is a default, and you're probably going to want to get, again, something like 50 hertz, so that when you run it, you can actually see things happen. Uh, Now, what we're going to have is this is for simulation. This clock here is so that I can get my counter to count. Um, that's for simulation. On the actual breadboard that I provided for you guys with all the 7 segment or the LEDs, it also has the clock part on there, and I made the clock. I made that with a 555 timer. And so what you're going to be doing is taking that information and sending that in to that pin when you actually make it. On the digital electronics breadboards, those FPGA boards, there are only certain GPIOs that can have a clock. You can't just randomly pick every one. And GPIO 0 is definitely one of those inputs that can be a clock. So we're just going to use that. So for simulation purposes, you hook it up like this, you wire everything together, you have your gates under here. One thing I want to show you, if you do a Control C and say I want to hook up C right down in here where I'm circling my mouse, if I did Control V or paste, watch what happens. C_1. That physically is not the same as this. If you wanted to have an on-page connector that would be equivalent to C, what you're going to need to do is go to Place, Connectors, On-Page Connector. I'm going to rotate around just because I'm dorking out. And then from the list, you pick C, which is our least significant bit, and then you would go ahead and you wire it up. If you copy and paste on-page connector, C1 is not the same thing, so it will not know what the heck C is doing, this guy right up in here, because it doesn't know that. It just kind of, it's like copying the name but adding onto it. I don't know why multisim does that by default, but that's what it does. So just keep in mind that if you're going to be putting on-page connectors, say like L1 and 5, here'd be 1, 2, 3, 4. There'd be L1, and that's L1 and L5. If I want to put an on-page connector and hook it up to these guys, what you're going to want to do so you can see this guy, when you simulate, what you should see it do is go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And with these guys, if you want to make an up counter, make it up. If you want to make it down counter, make it down. It doesn't really matter. It just makes certain, if it's down counter, obviously you want to see it go 6, 5, 4, 3, 2, 1, and then just keep on going. You don't want to see 0 or 7 on these guys. Definitely choose a red. Don't pick a clear. It may throw you off, and it throws me off on occasion. So we've talked about the key things here, the MSB, the truth table, inputs versus outputs. I kind of got off track on that. But this clock, that's sending information in right here, right? So do you think that should be an input or an output? It's sending information in. And what you have to do is you have to think from the FPGA standpoint that those actual connectors, are they taking information in or are they taking information out? And that would tell you whether it's input or output. So if you think about it from the FPGA standpoint, the clock, this GPIO 0, which is physically a 555 timer circuit that I provided for you, that is information that's going in. So when you double click on this, it better be set up for an input. As far as these guys here, these GPIOs, okay, from the FPGA standpoint, are you taking information in or are you sending information out from the FPGA to the LEDs? Now, if you think about it, you've got to send the information out to the LEDs, say, hey, turn on. So these, you're going to need to change their mode to output. You're going to need to do that for all of them, okay? And I'm not going to do all of them, but you need to change those for outputs, and this is what you're going to see. See how that symbol changes? If you go ahead and program it like this, it's not going to work. Those LEDs will not light. So you need to set them up as outputs. Obviously, I'd have to have an on-page connector over here and connect up L1 and L5, and You know, you could, if you want to get real ugly with it, you could do something like that. You know, no one's saying you have to get all fancy and pretty like me, but um, that's an option for you. Um, let's see, there was one other thing. Oh yeah, when you go to simulate, so you verify that everything works on here. When you're ready to program, the only thing that you need to do is you need to delete that clock. If you program with the clock, it's just like back in the when we did FPGAs early in the year. If you program with those interactive switches, those ons and off, the ones that could be a 1 or a 0, it won't work, so you have to delete that. Um, but one of the things you need on here, like your presets or clears, depending on what you're trying to do, the digital highs can stay. That's basically equivalent of ECC. So I don't know if this is what you'd end up with in the end, but you know, you'd probably have something like this. You're gonna have to have a toggle. Um, so those can stay. The digital highs can stay. Digital lows can stay. But you can't program with the clocks, and you can't program with these interactive digital constants. Okay. So if you did, it won't work. Um, and that's it. So basically, once you get everything set up, get everything wired up, you verify that it works using the clock. Then you delete that, program it, and hook up the wires. Everything's labeled pretty clearly. And I think you'll be pretty psyched. It's pretty cool to see this thing run. All right. Well, thank you very much. Have a good one.